Hello students, welcome to the sixth video in the series Microwave Layout Analysis. This is a layout of a 2:1 multiplexer using transmission gate as a building block. As we see here, this is my first transmission gate Tg0 because it is accepting the input I0 of multiplexer, while this is my Tg1 because it is accepting the input I1 of multiplexer, and here is the select line of the multiplexer. Let us remind ourselves from the previous video on transmission gate. The transmission gate turns on for control signal C equal to 1, and control signal C is the signal which is given to the gate of NMOS. And we should also remember that PMOS and NMOS devices turn on when the respective gates receive logic 0 and logic 1 respectively. Let us analyze this layout to justify whether it gives the functionality of a multiplexer. That is, in a multiplexer, when select line S equal to 0, the output is equal to the input I0, and when select line equal to 1, the output Y is equal to I1. So let us draw the truth table. S and Y. S equal to 0, S equal to 1. Let us see what are the values of Y for select line equal to 0 and 1. When select line is equal to 0, this 0 goes to the gate of PMOS. Rather, let us name the PMOSes. P1, N1, P2, N2, P3, N3. For select line equal to 0, the gate of PMOS P1 receives a 0, and the gate of NMOS N2 also receives a 0. So P1 is on, N2 is off. Select line equal to 0 is given to the input of the inverter 0. Inverter converts 0 into strong 1, strong 1, strong 1. Strong 1 is given to the gate of NMOS N1, and strong 1 is also given to the gate of PMOS P2. So N1 turns on and P2 turns off. In other words, the upper Tg0 is on, and lower Tg1 is off. So the input I0 is transmitted here. I1 cannot be transmitted here. Hence we conclude that Y is equal to I0. us analyze the same layout for select line equal to 1. Select line equal to 1. Select line equal to 1 is applied to the gate of PMOS P1, and it is also applied to the gate of NMOS N2. So P1 is off, N2 is on. Select line equal to 1 is given to the inverter. Inverter converts it into strong 0. We have strong 0 here. We have strong 0 here. Strong 0 or logic 0 is applied to the gate of NMOS N1. So N1 turns off. Strong 0 is applied to the gate of PMOS P2, and P2 turns on. So in essence, Tg0 is off and Tg1 is on, because of which I1 gets transmitted to the output node and I0 cannot get transmitted. Hence we conclude that Y equal to I1. Thus we can see that after analyzing the layout which we have made for a 2:1 multiplexer, it does satisfy or fulfill the truth table of a 2:1 multiplexer. Let us see the simulation. So we can see here that when select line S is equal to 0, the input I0 is selected and it is sent to the output Y. And when select line is equal to 1, the input I1 is selected and sent to the output. Hence, these waveforms also justify the truth table of a 2:1 multiplexer. Thank you very much.